Huh. So GraphQL. So before going for a GraphQL, let's know why we need GraphQL. So before, what we used to do is, suppose for example we are creating a website, we have backend and we have front end. What we do is, if a front end, like for example, suppose front end wants to ask what is the name of user, so there must be some API that front end have. For example, there may be www.xyz.com/users, something like that, and what it will be sending in response, it will get the data from your database. Backend will get your data from the, let's suppose, database. So what backend will do, it will ask what is the name for database, then collect the data and send it to you in the form of something like JSON or something, but like it will give you every single data related to the user, how you define in a backend, like first name, like Ajit, middle name, suppose you don't have any, and last name, something Thompson. If I talk about age, 19, address, a simple address, India, and phone number, uh, 99999, something like that, all this. So for a particular user, he's getting a lot of data. What he needed was just the name of the user, but because there is only one endpoint exist related to the user, from that you have to query the username. So just to get the name of the user, you have to accept this much of data. After that, you can, in front end, you get that data and will say dot first name plus, like when you get the data in the front end, what you will say, data dot first name plus data dot middle name and plus data dot last name, this something, and this will be shown to the user. So it is good, but the problem is, still we were asking for the name, we are getting this much of data which is not needed. Sometimes it may have multiple things which is not needed, and this is creating the issue. For example, if the user is not logged in and we just want to get the username, and we are sending this much of data, which is very wrong. So there comes one option that why we are sending this much data. Will create, just to know the name of the user, what we will do, we'll create a new API, user name. This will only give me this much of data, right? It is good. Now the problem is resolved. But for example, now we ask for what is the age of the user. So you will say we will create another API user age. It will just give me one thing, age, like 19. But what if we want name and address of the user? So using we will create another route with username and address. So but the problem here comes, like for just simple things you have created multiple routes which are not easy to handle. If your project becomes too big, you will not be easily able to handle this, which is the problem, and that's why we need to solve it. And because the only major problem is you were sending a lot of data before, and which is not very good, and to get the solution for it, you think that we will just divide it in simple routes, which is also not a good option. What we can do is we need some new technology. So here comes the GraphQL, what it is designed for, which I basically got to know from the somewhere, and now we are going to learn that GraphQL. So let's see what GraphQL is. Introduction to GraphQL. Learn about GraphQL, how it works and how it is. GraphQL is a query language for your API. So GraphQL is a query language for your API and a server-side runtime for executing queries using a type system for your data. Okay, let's go line by line. GraphQL is a query language for your API. So what does a query language mean? So what it basically mean to say is that, like, it's your backend, and if it's your front end, and if there is any API, the route you have, you can add query to it, like that. For every route you define, you can query things. It's a query, means you can query on the API. Okay, it's something new. And a server-side runtime for executing queries using a type system you define for your data. Okay, there are two terms that kind of I don't know, but server-side runtime for executing queries and a type system you define your data. So server-side runtime for executing queries, which means that whatever the query you write, it is going to be executed in the back end, not in the front end. Queries will be executed on the server. So which means no data is going to come into no data will come to client then query, but it will be only query at the back end, and from that the specific part of the data that you want will be sent to the client. And using a type system. Okay, so type system is something new which I don't know. We'll see later what does that mean. So basically I think that they have their own form of storing the data, like they store the data in some other form. So it may be. The GraphQL specification was open sourced in 2015. So GraphQL was open source, means open source in 2015, and since been implementation in variety of programming languages. Okay, so GraphQL is not limited to single programming language. What I was thinking means GraphQL is not only for JavaScript. GraphQL is not only for JavaScript. It may be used by multiple languages. And okay, GraphQL isn't tied to any specific database or storage engine. It's backed by your existing code and data. Oh wow, so it's something very different. Like, what you mean to say is that it's not tied to your database, means it's not specific to the database. For example, what kind of database we can have? MySQL, maybe too boring. MongoDB, or we can have Postgres, any of this. Then there comes your backend, which is interacting, and then comes your backend comes for the no there's a backend something different. Here's the backend that is handling the query. There comes one layer which is GraphQL. So it's actually like that something, and this is your front end. What happens if you send any API request, for example, query, the backend takes this request. GraphQL understands what the query means, and it will interact to any type of database that you are using. It's not specific to MySQL, it's not specific to MongoDB, it's not specific to Progress, and it's even not specific to backend, means which programming language you have made it. So it can work with multiple programming languages, it can work with multiple database, and after GraphQL process the data, it sends to backend, and backend responses with the data. So backend can be, I can say, backend can mean any programming language, JS, Spring Boot, .NET. Maybe we will know what languages it support, but the basic architecture is like this. It can interact with any of the databases. It's just acting like a whole layer. Like, this is a whole backend that we have, the one that is interacting with the query. Then comes the query is then transferred to GraphQL is going to process it, and after processing it can interact with any of the databases, because it's not specific, isn't any specific database or storage engine, it's not specific to anything, and it will process the query, and then it will send you the data. So front end gets the data. Okay, describe your API with a type system. So now we are getting into the type system. That what is type system that we have known here, that type system that we thought that some type of data that it is storing. A GraphQL service is created by defining types and their field. Okay, you create a GraphQL service just by defining the types and the fields. Types is that, I believe that, let's see, and then writing a function for each field to provide the required data. For example, a GraphQL service that tells you the name of logged in user metric like type query, then field, and every type you define is associated with your function that will get the data for you. Okay, so what I understand from this is that there is the type means which type of data it have. Oh wow, we have something arrogant. बनाएंगे. It has something like this. It has fields. uh, Fields means that the data you want, the you can say the data I want, actually the data I want, and it's a category which type of data it is, and the data I want means इस तरह से नहीं. Type is something like, see, it's a query for the user, and it's a user the name. Okay, it's a little bit just to get the name. Okay, to get the logged in user, what I am doing is first querying me user if I am the user or not. First it is a query whether I am the user or I am not. Then if I am the user, then it goes into the user database, user model, and then gets the string from the data for me. So I can say better like I can say type is a database. Type I can say is the model. Yeah, it's a model, and field is the model specific data. Like for example, what we did, we create in our backend users data बनाता है, उसके अंदर name, age and address, all those things we feed. So in users table there is all these categories. So what kind of type it is a user which is having all this data. Okay, got it. And for every type you define, for every type there is a specific function for it. Function to get data. Okay, along with the functions for each field, like resolver query. Yeah, that's resolver. In the example about the function that provides data for the me field on the query type uses the information about the authenticated user who made the request, while the name field on the user type is populated by using the user ID to fetch their name. Okay, that's what we learned. Now query exactly what you want. That's the main thing. You just ask what you need. That's a simple. After a GraphQL service is running, typically at a URL on a web service, it can receive GraphQL queries, okay, to validate and execute from clients. As GraphQL means, as your GraphQL services start to running, you can add your queries in the URL only, and GraphQL can fetch that to validate and execute. It will first validate it and then execute it. The service first checks a query to ensure it only refers to the types and field defined for the API. Okay, so what it does is, the service is always check a query to ensure it only refers to the type, it only refers to the types and fields defined for the API, and then runs the provided functions to produce a result. It's not like that you can ask anything from the API. Means you can't query anything from the GraphQL, and anything in the query. You can't query anything in the GraphQL. Yeah, only those which are defined. And what does define mean? Which types are defined and its field. Okay. So for example, the query me name could produce the JSON result data me name, क्योंकि मी क्या है यहाँ पे टाइप है जो कि पहले डेटाबेस में स्टोर्ड है और नेम उसका नाम है. With even a simple query, we can see some of the key features that make GraphQL so powerful. The client can make queries to the API that mirror the structure of the data that they need, and then receive just the data in the expected shape with a single request, and without having to worry about which underlying data or source it is provided. Okay, so the best part is the way you ask the data, you will get it in the same format. The best point is, for example, if you ever seen like when we ask the data, it is in chunks. Like for example, if we normally see what we do in the past, data can be of any shape. It's not specific. We have to define that. For example, if I want to send the age, it may be, for example, if I want to send the name, for example, this may not be my architecture. My architecture might be like this. Oh. So what it is like first name, but I can give the data in, like for example, in simple name style, like why different Ajit Thompson, simple. So in front end I have to define what type of data structure, what type of way I want, and according to that I make things. But in GraphQL, whatever the style you ask for, you will get that only. That's why it is more powerful. If this is the style you ask for, you will get it in this style only, as you can see. Double. Yeah. Evolve your API without versioning. Client requirements change over time, and GraphQL allows your API to evolve in response to those needs and without the overhead of managing different API versions. For example, if a new feature calls for more specific name to be available, then user type could be updated as follows. Okay. So it also solves the problem of API updating, because what happens if users requirement for the API increases, and for example, as I've asked, if he don't wants the name but he wants the first name and a full name, what he wants this, not this. So it's basically easy in that you just have to add, there's at the rate deprecated kind of thing, and you just add the reason with that. So if you, before using name, you just, before after that field you just add deprecated and add the reason, and you add your new fields in that. So client tooling will encourage the developer to use the new fields and remove usage of the deprecated name field. The field can be removed once it is determined it is no longer used. The field can be removed once it is determined determined it is no longer used. In the meantime, GraphQL will continue to provide its data as expected. ओके, ये सिंपल क्लाइंट को डेप्रिकेटेड बता दो और उसके बाद अपना काम चालू करो. ट्राई इट आउट. द बेस्ट नेम वे टू लर्न द GraphQL इज टू राइटिंग द क्वेरीज. फॉर एग्जांपल नेम. ओके, इधर तुमने नेम लिखा, इट गिव्स इन द स्टाइल ऑफ दिस. फॉर एग्जांपल इफ आई जस्ट ऐड I just want the data full name like ads from the friends. Okay, field friends of the character must have a sections of subfield name. See, you get the data like that format. And if I say I want the name of friends, like what it will, field name must have a selection since type string has no subfield. The subfields need, so that's why you can use friends, the name, you will get the name. Also if you want the type name, you get the type name. But what, and if you want the name also, you will get the name ID. If you want the friends connection, which also takes their name, no, what it has, friends. Oh, see, type name, friends connection. It's like that. What type it is, human. So you can get the data actually just by adding the fields in the query. If I add just the field name here also, what I will get at the name. So now you know those concepts. Yeah, we got to know very much things about the GraphQL. What first, it's not specific to any programming language, any database, or any storage engine. Second, it powers us to query in the URL, and it gives data in the format you ask. API versioning becomes easy. Like all these are the basic things that you will notice. Okay, let's go in schema and types. Schema and types. Learn about the different elements of the GraphQL type and system. The GraphQL type system describes what data can be queried from the API. The type systems describe what data can be queried from the API. Okay. The collection of those capabilities is referred to as the services schema, and clients can use that schema to send queries to the API that returns predictable result. It's a lot of terms actually. The GraphQL type system describes what data can be queried from the API. Okay, means basically what he wants to say is simple. The type you define, it's only what I can query in the API is all in the types. What are the type I define? The type I define, the type I will get to query. Simple. The collection of those capabilities is referred to as the service schema. Okay, it's kind of called the service schema. Okay, it's just like that. It's a service schema, and clients can use that schema to send queries to the API that returns the predictable result. And clients use this schema only, means the type is kind of a schema that the client will know to understand what type of data it is being storing. Okay. On this page, we will explore GraphQL's 6 kinds of name type definition. Okay, there are kind of six kinds of named. The type is of basically 6 types, I suppose. There are of 6 types, as well as the other features of the type system to learn how they may be used to describe your data and relationship between them. And we'll know how we'll create the relationship between that. For example, if you want this two data, how we can get that. Since the GraphQL can be used with any backend framework or any programming language, we'll avoid implementation specific detail and talk about only type system. If you have seen GraphQL query before, you know that GraphQL query language is basically about selecting fields and object. Yeah, you just select the fields, you just select the object, you get the data. So for example, if I ask for me in this hero type, I just want the name and appears in. So a hero type, I just got the name and appears in this movie. We start with the special root object. We select the hero field, and for the object returned by the hero, we select the name and appears in. So what do you think? This is a root, this is a hero field, and this for the object returned by the hero, we select the name and appears in field. We name or appears in field को हम चुनते हैं इसके अंदर. Because the shape of GraphQL query closely matches the result, we can predict what the query will return without knowing that much about the server. Yeah, obviously, because जो हमने भेजा है वो हम जानते हैं किस तरह से रिजल्ट आना. So we are very much relaxed what kind of data we are going to get. But it's useful to have an exact description of what data we expect. For example, what fields can we select? Obvious. What kind of object might they return? And what fields are available to those sub-objects? These are basic questions. What fields we can select? What objects? That's where the schema comes in. So schema's role is basically first, what fields we can select. What the object's output will be. And the third, what field we can select, what kind of object may return, and does the field have sub-object or not? We don't know about that. So with a schema we can get to know all these answers. With that we can know the answers of all these questions, because schema is the visual thing. That's where schema comes in. Every GraphQL service defines a set of types that completely describe the set of possible data we can query on that service. Then when requests come in, they are validated and executed against that schema. Type language. GraphQL service can be written in any language, and there are many different approaches you can take when defining the types in the schema. Some libraries have you construct the schema types. Okay, GraphQL service can be written in any language, and there are many approaches you can take when defining the types in the schema. That's good, that's not a trouble. Some libraries have you construct the schema types, field and resolver functions together using the same programming language that was used to write the GraphQL implementation. Okay, in some libraries, what you have to do is you construct your schema, the field, the resolver functions, all in the same programming language in which the GraphQL is written. Okay, in some libraries, the next point is Some libraries allow you to define types and fields more ergonomically. What does ergonomically means? In a way that makes furniture or equivalent comfortable, I think more comfortable using what's commonly called the schema definition language or STL, and then write the resolver function for the corresponding field. And so in some type of library, what you do is you define the type, you define the field in a schema definition language. The way, what kind of a schema definition language it is? Also XML type actually. Okay, the term user, and then and you separately write the resolver function. Some libraries allow you to write and annotate the resolver function and then infer the schema from that. What does that mean? And some libraries may even infer both the types and resolver functions for you based on some underlying data sources. So there are four types of varieties he's talking about. Like you write, is saying that when you GraphQL implement. Okay, so first he's saying write the schema, field and resolver function in GraphQL language only. Okay. Second, write the schema field in the schema definition language and resolver in that language. And third, you can say write the third is what I was trying to understand, that allow you to write and annotate the resolver functions and then infer the schema from that. What those? Let's take the help of ChatGPT and understand what does it mean. Learning GraphQL from doc got below points. Explain in simple terms with simple and brief. Normally in GraphQL you first write the schema and then write the resolver, but some libraries flip. You just write the resolver function, the code that fetches the data and the schema is inferred out. Okay, you just only have to write the function and it basically gets the data. This is also first approach. Okay, you write the hello world, the library sees this and infers the schema. वो library अपने आप ही जान लेती है कि तुम क्या कर रहे हो. Infer both types and resolvers. Some advanced libraries don't even need you to write resolvers. They can look at your database or another data source and auto-generate both the schema and resolver. Suppose you have a okay. You just write the type and then both they automatically generate the query and resolver. Okay, so for example, you write the resolver function automatically schema and field will be made. And the fourth, you just define the schema and it's solved. Automatically it will define the resolver for you. That's the basically more advanced. Okay. Since you can't rely on a specific programming language to discuss GraphQL schemas in this guide, we will use SDL because it's similar to the query language that we have seen so far and allows you to, we are going to follow this approach only. Okay, this approach. Object types and field. Okay, let's take a break. So let's move forward and know object and types. The most basic component of GraphQL schema are object types, which just represent a kind of object you can fetch from your service and what field it has. In the STL, we represent it like this. Okay. So what actually it means is like this. When to create a type, you just write the type and the object name you're talking about, and there are field field name 1, field name 2, and simply like this. So here the language is readable, but let's go over it and we can share the vocabulary. Character is a GraphQL object type. So as I told, this is the object, that it meaning it's a type with some field. Most of the types in your schema will be object type. Most basically that there may be other than object, like for example something else, but here currently we are talking names and appears in the fields of the character type. That means the name and appears in are the only field that can appear in any part of GraphQL query that operates the character type. String is one of the built-in scalar types. Okay, there are, for example, you type the string, which is a scalar type. These are types that resolve a single scalar value and can't have sub-selections in query. We'll go scalar types more later. Okay, so we got this type of object. This is an object type. There is one called scalar type, which means can't have subtypes in it, like string. Okay, single scalar value can't have sub selections in the query. Okay, can't have sub selections. This is a little bit different. Selections in it. Okay, can't have sub selection in the query. We move more. String not means that a field is non-null type, meaning that GraphQL service promises to give you the value whenever the query this field. In SDL we represent this with an exclamation mark. Okay, so adding exclamation marks makes it kind of non-null type, which means it is guaranteed that it is existing. Good. This is important in SQL. What we write to make this field compulsory that it may not be blank. Something mandatory field. No, because if you want to check, required fields are missing. How this is whatever not null. Yeah, it's just like having not null in the data. An episode is a episode, and this is a list type, and then another comes the list type, which is just that. It will give you the list of objects, which is when the list is not null, you can always expect an array with 0 or more items when you query the appears in field. In this case, episode not is also non-null within the list. You can always expect every item to be an array in the episode object. Got it. Explanation makes that this object is not going to be non-null. If you call it, it will always respond with some value. It will awesome. Okay, you know that what a GraphQL object type looks like and how to read the basic SDL. Now got it. Arguments. Every field on a GraphQL object type can have 0 or more arguments, for example the length. Okay, I can add the arguments unit, length unit. All arguments are named, unlike languages such as JavaScript and Python where functions take a list of ordered arguments. All arguments in GraphQL are passed by name. Specifically in this case, the length field has one defined argument called unit. Okay, so you can also, every field can have arguments. So every field can have the argument like field name argument, type argument, key argument, value. It's like that. Key and value can be anything, just like functions. Okay, but if you want that if you want argument is required, means kind of what it say, it can be either required or optional. If you want is optional, if you argument can be optional as well as required, but it can be to make it optional, give default value. Means simple है. If you field name argument key argument value equal default value, this will make it optional. Simple. If the unit argument is not passed, then it will unit by default meter will set. The query mutation and subscription type. Okay, mutation, very different term, and subscription. Every GraphQL schema must support query operation. Okay, it will support the query operation that I got. The entry point for this root operation type is a regular object type called query by default. Okay, so every query is kind of the query type. Every object is a kind of query type. So if you see a query, that means GraphQL service needs to have a query type with a droid field. Type query droid ID. Schemas may support mutation and subscriptions options. I'm kind of now overwhelmed. What does this mean? Let's drink water. It's not that much actually. There you go. Every GraphQL schema must support query operations. It's important for every GraphQL, the schema that we defined, it must support that the query can be handled. The entry point for this is root operation type. So for example, anytime you create a query, for example, anytime I create a query, it is under the root, and after that I add the field like name, like the object, then name. So what is this? This is a root, means root query type. This is the object type, and this is object field, kind of like that. So that means GraphQL service needs to have a query type with a droid field, droid ID, droid. Schemas may support mutation and subscription operations by adding additional mutation and subscription type that and then defining fields on the corresponding root operation type. It's important to remember that other than a special status of being entry points in the schema, the query, mutation and subscription types are the same as any other GraphQL object type, and their field of work exactly the same type. You can name your root operations type differently too. If you choose to do so, then you will need to inform GraphQL of the new names using the schema keyword. The schema query, my query type, my mutation. Okay, because we need to continue, we should understand what mutation. Just explain what mutation and subscription is in the GraphQL. Is an operation used to modify the data. Okay, mutation means to modify the data, similar to put post j. Unlike queries which are read only, mutations change a state on the server, also return data often. And subscription is a long-lived operation that lets client listen for real-time updates from the server, works over persistent. Okay, kind of mutation is something that returns the data. Mutation is something that's query also. So kind of put post in the WebSocket thing. Okay, kind of get the idea. It's some kind of query format that we need to know. Let's go again. Scalar types. A GraphQL object has a name and fields, but at some point those fields must resolve to some concrete data. That where scalar types come in. They represent the leaf of the query. In the following query, the name and appear in fields will resolve to scalar types. How this? Because those fields don't have any subfield, they are the leaves of the query. The GraphQL with the set of default scalar types are out of box: int, that stores 30-bit, then float, then a string, boolean, and an id, a unique identifier often used to refetch an object or as the key for a cache. The id type is serialized in the same way as the string. However, defining an id as an id signifies it is not intended to be human readable. Okay, so you can say that I can write here only the scalar and float, anything else, string, boolean, and id. There's a specific thing about the id. There's a specific thing about the id is just the string only, but it is intended to be not human readable, something like that only. Okay, so in most GraphQL service implementation there is also a way to specify custom scalar types. Okay, we can define the custom one. For example, if we want to define a date type, scalar date, then it's up to our implementation to define how that type could be serialized, deserialized, and validated. For example, you could specify the date type should always be serialized into an integer timestamp, and your client should know to expect that format for any date fields. Okay, so you can create your own custom scalar also. Can create your own custom scalar like scalar date, और तुम इसको खुद ही serialize, deserialize, you can serialize it, deserialize it, and validate it. मैं इस यूज़र को पता होना चाहिए कुल मिला के, ठीक है. Now come to enum types. Okay, it's something different अभी तक नहीं देखा. Enum types, also known as enumeration type, are a special kind of scalar that is restricted to particular set of allowed values. This allows you to validate that any arguments of this type are one of the allowed values, communicate through the type system that a field will always be on one of a finite set of values. Here what enum types look like. Enum is just like the struct, I suppose. This means whatever we use the type episode in our schema, we expect it to be one of the. Okay, enum is just like options. Enum type options, simple. You're just giving it a options. So that's means GraphQL service implementations in various languages will have language specific way to dealing with enum types. In languages that support enums as a first class citizen, the implementation might take advantage of that. In a language like JavaScript with no enum support, these values might be internally mapped to a set integer. However, these details don't leak out to clients, which can operate entirely in terms of the string names or the enum values. Now modifiers. Types are assumed to be nullable and singular by default. Okay, they can be null and they can be singular. However, when you use these named types in a schema or in query variable declaration, you can apply additional type modifiers that will affect the meaning of those values. What does nullable and singular mean? I don't understand. In GraphQL, when you define a type for a field or an argument, that default assumption is that it is both nullable by default. If you declare a field just as a string, it means field can either return a string or null. You must explicitly add dash modifier if you want. Okay. Singular, if you declare a type as string, it means single string value, not an array. If you want to list an array, you must explicitly wrap it in a bracket. Kind of. तो इसको ऐसे लिखने की क्या जरूरत है? Stupid. As we saw with the object type example above, GraphQL supports two type modifiers, the list and non-null types, and they can be used individually or in combination with each type. Okay, not null, सीधे ये लगा दो. Here we are using a string type and making it as a not null by adding an exclamation mark after that time. This means that our server always expects to return a null value for this field, and if the resolver produces a null value, then that will trigger GraphQL execution error, letting the client know that something has gone wrong. As you saw in the example above, the non-null type modifier can also be used when defining arguments for the field, which will cause the GraphQL server to return a validation error if a null value is passed as that argument. So we can pass it, means we expect the type for the null. We can't just list. List works in a similar way. We can use a type of modifier to mark it as a list type, which indicates that this field will return an array of the types. In SDL, this is denoted by wrapping the type in the square bracket. You just write the arguments. Okay, it works for the argument. So as we see the above, the null and the list modifiers can be combined. For example, you can have list of null. This means that the list itself can't be null, but it can't have any null members. List can't be null, but it can't have any null. For example, in JSON, this is valid, this is valid, this is valid, this will be error. You can't have any null values. You do need to have a value. This means that this list itself can be null. ये अपने आप में null रह सकती क्योंकि वो खुद में एक वैल्यू है, लेकिन क्योंकि एक सिंगुलर वैल्यू है ना, इसलिए, but it can't have any null members. Let's say we define a non-null list of string types. This means this list can itself cannot be null. This will be error, and this is possible. Oh wow. Lastly, you can also have a non-null list of non-null strings. This will be error, this will be error, and this will be possible. So for example, let's write this, or we can keep the screenshot of it. Like this. This will be something like that. Now coming to this, this. These are the something little different but good. Okay. You can arbitrarily nest any number of non-null and less modify according to your need. In GraphQL, there is no way to define a type so that fields data will only be considered valid if non-empty list is provided. In other words, would still be valid response if for a non-null list of non-null types. Yeah, you cannot exclude this. They mean to say that empty string will become. Okay, now coming to interfaces. How many things are there? Interface types. Like many type systems, GraphQL supports abstract types. GraphQL supports abstract types. The first of these types that we will explore is interface type. Okay, which defines a certain set of fields that a concrete object type or other interface type must also include to implement it. Define a certain set of fields that a concrete object or other interface type must also include to implement. For example, you could have a character interface type that represents any character in Star Wars trilogy. Okay, you can create your own object. Simple. This means that any type that implements character needs to have exact fields as well as the same arguments of the type. Oh, oops. In GraphQL, yeah, interface. Yeah, every same thing. This human implements character, name, ID. This implements the character. You can see both of these type have all the fields from the character interface, but also bring in extra fields. Extra fields add कर सकते हैं, total credits, a starship that is specific to that particular character. Interface types are useful when you want to return an object or a set of objects, but those might be of several different types. For example, note that the following query produces error. Primary function on a type character. Did you mean to use an inline fragment of a droid? The hero field returns the type character, which means it might be either a human or a droid. Wait, my puppy. So the droid field returns the type character, which means it might be either a human or a droid. Okay, yeah, obvious बात है. Human हो सकता है तो droid हो सकता है. Episode JT. In the query above, you can make only ask for fields that exist on the character interface type, which doesn't include the primary function. To ask for a field on a specific object type, you need use an inline fragment. Hero name ... on droid primary function. Astro match, because it is defined. Got it. You do need to implement when you define interface and create object from it, you need to keep all the fields defined in the interface, and you can add extra fields. For example, here the some important sometimes that might include implement the character. ये तो दिख चुका. To ask for a field on a specific object type, you need to use an inline fragment. Okay, this kind of thing for inline fragment. That's you need to ask. Interface types may also implement other interface types. Okay, interface can implement interface. Note that interface types may not implement themselves or contain any cyclic references to each other. While types may share common fields in a GraphQL API, that may not always warrant the use of an interface type to enforce that those fields remain consistently named. Interface types are a powerful way to indicate shared behavior across the types that implement them. When used, they should be semantically meaningful to the client developer, just like character. So, other point is that interface is just can't be cyclic, can't be cyclic, and can't contain cells like in C, but they can have another interface. While the types may share the common field in the GraphQL API, that may not also always warrant the use of an interface type to enforce that those field names remain consistently named. Interface types are a powerful way to indicate shared behavior across the types that implement them. When used, they should be semantically meaningful to client developer, just like characters is a useful abstraction. Okay, coming to the next. तो कर सकता हूँ. GraphQL supports a second abstract type called a union type. Union type shares similarities with interface type, but they cannot define any shared fields among the constituents type. A union type is defined by indicating its GraphQL supports second abstract type called union type. एक abstract type ये भी है, union type. Union types share similarities with interface type, but they cannot define any shared field among the constituent type. Let's see what that means. A union type is defined by indicating its member object types. Search result में human हो सकता है, ये हो सकता है, ये हो सकता है. Wherever we return a search result, type in our schema, we might get a human, a droid, or a starship. Note that the members of union type need to be concrete object type. You cannot define when using interface type. Okay, this is an important point. You cannot just do like that. You had the interface in that. In this case, if you query a field that returns such result union type, you need to use an inline fragment to be able to query. First, dot 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 on human name height, dot 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 on droid, dot 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 on starship. That would describe a starship name length. Search text and this should be concrete objects, but not the interface like this. Underscore type name field is a special metadata that automatically exists on every object type to the name of that type, providing a way to differentiate between data types and the client. That's also something you should care about. Also, in this case, since human and Android share a common interface character, you can query their common field in one place and still get the same result. So on character name, on human height, on Android primary function, on starship name length. On type name, human, oh, you can commonly ask all these things if they have that. Like for example, on Android have the function string. I will return that. Note that name is still specified on a starship because otherwise it wouldn't show up in the results given as starship. It's not a character. Input object type. Most of the examples we have covered on this page demonstrate how object, scalar, enum, interface, unit types may be used as output types for the field in the schema, but we have also seen that field arguments must specify their input. What type of input they want. So far we have only talked about using a scalar like enums or string as an input for the field. However, you can also complex objects as argument using input object type, which is a last kind of name type in GraphQL that we will explore. This is particularly valuable in case of mutations when you get the data, where you might want to pass in a whole object to be created in STL. Input object types look similar to regular object type, but the keyword input instead of type. This is an input type mutation. Create a review episode star ye. So there is another type called input type, the final one. This is the last type. Don't have anything. There is how the object is created. You create as for the input. For example, mutation created row episode. This is the input you gave, post, and the data you get, stars and the commentary you get. The field on an input object type can input object type, but you can't miss input to an object types in your schema. Input object type also can't have arguments on the field. Okay. Now coming to directives. There's something called, in certain instances where field arguments are insufficient or certain common behavior must be replicated in multiple locations. Directives allows us to modify the parts of the GraphQL schema or operation by using @character. So what I mean to say, @ is known as directives. Good. Type system directive allow us to annotate the types, fields, and arguments in a schema so that they may be validated or executed differently. Directive may also be defined for the use in GraphQL operation that are executable directives. The GraphQL specifications defines several built-in directives. For example, implementation support for @deprecative directive will be available to annotate deprecated parts. Simple. Why you want me to define @deprecated directive in your schema explicitly? You can define it also. Its underlying definition would look like this. Note that just like fields, directive can accept arguments, and those arguments can have default values. The deprecated directives has a nullable reason argument that accepts a string as an input and falls back to the no longer support. And with the directive, we must specify where they may be used, such as field definition or a enum value. In addition, the GraphQL built-in directives, you may define your own custom as with a custom scaler. तुम अपने custom scaler बना सकते हो, custom directive. That's about the choosing. That's all. Documentation, description. GraphQL allows you to add documentation to the field types and arguments in your schema. In fact, the GraphQL specification encourages you to do this in all cases unless the name of the type field argument is self-descriptive. Schema descriptions are defined using the markdown syntax and can be multi-line or a single line. Okay, triple line के अंदर तुम लिखते हो और डबल कोटेशन मार्क के अंदर वो कर देते हो. It's a simple documentation. In addition, to make the GraphQL API schema more expressive, the description can are helpful client developer because they are invaluable intersection queries visible in QL tool, developer tools such as GraphQL. Occasionally, you may need to add comments in the schema that do not describe types, field, or arguments and are not meant to seen by clients. In those cases, you can add the comment. Okay, there are two things. Documentation, which you can write with this dot 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 dot. This is multi-line dot 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 dot, like that. But you may also write in single line dot dot dots, and these both are visible to developers and client. But what we want is comment. So comment will only be visible with hashtag only visible to developers, not the stupid ones, the client. Comments may also be added to the client queries. Hashtag, that's you will not get, but if you just do like this, you will get the query. Next steps to recap what we have learned. Depending on what library is selected to build the GraphQL service, we can define a schema in a language agnostic way using SDL, or by compiling the schema from the code that provides the data for its field. There are 6 kind of type definitions: object, scalar, enum, interface, union, and input. Object types contain fields that specify output types, and those may have argument that specify input types. End, float, string, boolean, scalar types, and scalar type. Enum type represents leaf values in the GraphQL schema, but they are limited to finite set of values. Enum मैं फिर से भूल गया, बन गया enum type. Options, list, नॉन लिस्ट, जो उसको नलेबल सिंगुलर से अलग बनाते हैं. इंटरफेस यूनियन एब्स्ट्रैक्ट टाइप्स होता है जो कि कॉन्क्रीट टाइप को डिफाइन करने में होता है. इनपुट ऑब्जेक्ट ये कॉम्प्लेक्स वैल्यूज़ को पास करने में मदद करता है म्यूटेशंस में. टाइप सिस्टम डायरेक्टली कैन बी अप्लाइड टू द टाइप्स, फील्ड एंड आर्गुमेंट इन अ स्कीमा टू alter how they are validated and executed during the query. GraphQL support the schema documentation using type, field and argument descriptions, and it is also supports comments that are ignored by the parser. Okay. Now that you understand the key feature of the type system, you are ready to learn more about the query data, and that's the queries. And we have half an hour before we could end this, and I think we can go with queries. We will take a little break and start the queries. Queries. Learn how to fetch data from a GraphQL server. That's more important. Now we are going to know actually how we can get the data from the GraphQL. GraphQL supports three main operation types: queries, mutations, and subscriptions. Okay, what does query mean? First we should understand that query means can't we just queries can't we just remap first, setting, open, export, no, yeah, I just want to, oh hey, VRDOALOT, that's there, but it's showing number, frame to text or wireframe to code. What this thing is also available? What is that is? समझा नहीं क्या था ये. Text to diagram. This is something. Backend and frontend explaining the GraphQL in between. Mermaid यूज हो सकता है लेकिन resolve mutations. Oh, it's good. I don't know that Excalibur was also having this thing. Front end queries भेजता है, resolvers backend उसको resolve करता है, queries request करती है, mutation data भेजता है, subscription real time updates के लिए होता है. Amazing. But what it is, I don't understand. Means I don't understand. Let's don't think so. What I wanted was some setting option to 1 2 3 4. ये मुझे वो दिखा रहा है. Save to open, find canvas, ये theme English, theme English ही चाहिए, no trouble, canvas background, that's good. That's the thing. I don't know what is. I just wanted one thing. How to change things. Excalibur is becoming too big actually. Software architecture diagram, system design concept, architecture diagram concept, software logos, stick figures, AWS, shape URM, awesome icons, cloud, basic wireframe, data design. That's okay, move on. We don't have a time. Queries. What we are going to do? Queries, okay. So queries basically, what does it mean? fetch data from GraphQL server. It's client who sent the query, which means get the data from the GraphQL server. Well, we haven't known form of GraphQL query. Oh, Graph query language. See, I'm smart. I'm very smart. GraphQL supports three main operation types: queries, okay, mutation, and subscription. Okay, it has three things. GraphQL basically have three things. GraphQL have three things. 1, 2, and 3. Oh, you can turn it like that also. Queries, mutation, and it again, that is subscription. Okay, these three things. We have seen several examples of basic queries in this guide, and on this page you will learn detail how to use various features of a query operation to read the data fields. It's the simplest GraphQL query is about asking a specific field on an object. Start by looking at the hero field that's defined on the query type is a schema. Type query hero character, and this we are asking for. So we are just simply asking the field. So what we did is we defined the query where hero is the character and hero का मैं कुछ भी जानना चाहूँ मैं उसको field में लेके जान सकता हूँ. In creating a GraphQL document, we always start with the root type. As I said, everything is a root operation type. The query object for this example, because it serves as an entry point for the API. From there, we must specify the selection set of fields we are interested in, all the way down to their leaf values, which will be scalar or enum types. The field name returns a string type. In this case, the name of the main hero of Star Wars is a take. GraphQL specification indicates that a request's result will be returned on a top level data key in a response. If the request raised any errors, there will be information about what went wrong on the top level errors. From there you can see that the result has same shape as the query. This is essential of GraphQL because you always get back what you expect and the server knows what fields client is asking for. In the previous example, we just asked for the name of our hero, which is returned as scheme, but the field can also return object type and list thereof. In that case, you can make sub selection of fields for that object type. GraphQL queries can traverse related objects and their field, letting clients fetch lots of related data in one request instead of making several round trips as one need to be in the classic REST architecture. Note that in this example, the friends list return an array of items. GraphQL queries look the same for a single items or a list of items. However, we know which one to expect based on what is indicated in a schema. Arguments. Now coming to arguments, as we know that arguments can be passed in heavy also. If only thing we could do was traverse object and their fields, GraphQL would already be very useful language for data fetching. But when you add the ability to pass arguments to the field, then it's got more interesting. Query human, ID human. The client must then provide the required ID value with the query human. Yeah, then only he can get the name. In a system like REST, you can only pass a single set of arguments, the query parameters and the URL segments in your request. But in GraphQL, in REST, what एक सिंगल सेट ऑफ आर्ग्यूमेंट्स होते हैं, क्वेरी पैरामीटर्स, और ये जो कि URL में पास तुम करते हो. But in GraphQL, every field and nested object can get its own set of arguments, making GraphQL a complete replacement for multiple API fetches. That's what I was talking about in the start. You can even pass the arguments into field that output scalar types. You can even pass arguments into fields that output scalar type. On one use case for this would be to implement data transformation once a server instead of every client separately. You can pass on. That doesn't mean to write. It's talking about that unit 4 5. Okay, arguments can be of many different types. In the above example, we have used an enum type, which is represent the one of the finite set in the unit of length. GraphQL comes with default set of types, but a GraphQL server can also declare custom types as long as they can be serialized in your transfer column. Operation type and name. In the example above, we have been using shorthand syntax where we omit the query keyword. Got it. Before the operations name selection set. In addition to specifying the operation type explicitly, we can also add a unique operation name, which is useful in production apps because it makes debugging and tracing easier. Here's an example that includes a query keyword as the operation type and hero name and friends as an operation name. Query hero name and friends, hero name and friends नाम की एक query बनाई जो कि ये ask कर रहा, तो उसने explicitly mention किया, बार बार हम root से चालू कर रहे थे, जो कि एक kind of इस तरीका नहीं है. The operation type is either query, mutation or subscription and describes what type of operation you intend to do. This keyword is required unless you are using the shorthand syntax for queries. It's always required for mutation and subscription. Additionally, if you wish to provide a name for your operation, then you must specify the operation. Okay, mutation और subscription के लिए very important है, तो हम इसको ignore नहीं कर सकते. The operation name is an explicit name that you assign to your operation. You should pick meaningful name. It is required when sending multiple operations in one document, but even if you are only sending one operation, it's encouraged because operation names are helpful for debugging and server-side logging. When something goes wrong, you see errors either in the network logs or in the logs of your GraphQL server. It is easier to identify a query in a code base name instead of trying to decipher the content. Okay, got it. Putting name is important because you can get the log of that thing. Think of this just like a JavaScript name, function name, your favorite programming language. For example, in JavaScript we can easily work only with anonymous function, but when we give a function a name, it's easier to track it down, debug our code and log within when it's called. In the same way, GraphQL query and mutation names along with the fragment names can be used for debugging too. Aliases. If you have a sharp eye, you may have noticed that since the result object field matched the name of the field in the query but don't include argument, you can't directly query for the same field within the different arguments. That's why you need aliases. Let you rename the result of field to anything you want. For example, if you ask the hero empire only, so it will create a table for which you got, so you can specifically add empire. This is the alias. I got it. Alias is something good, which is XYZ hero argument ABC hero argument. That's it. And the event two hero fields would have conflicted, but since we can alias the different name variables, so far we have been writing all of our argument inside the query string, but in most applications the arguments to field will be dynamic. For example, there might be a drop down that lets you select which Star War episode you are interested in, or a search field, or a set of filters. Amazing what he's saying. So far we have been writing all of our arguments inside the query string, but in most applications the arguments of field will be dynamic. For example, there might be a drop down that selects to select which Star Wars episode, or a search filter. It won't be good idea to pass these dynamic argument directly in the query string, because then our client code would need dynamic manipulate the query string at a runtime and serialize it into GraphQL specific format. Instead, GraphQL has a first class way to factor dynamic values out of the query and pass them as a separate dictionary. These are called variables. When we start working with variables, we need to do three things: replace the static value in the query with $variable name, declare $variable name as one of the variables expected by the query, pass variable name. Okay, for example, एपिसोड की क्वेरी है, वो वेरिएबल पास हुआ, the episode JD. For example, if you are working with a drop down menu, so in drop down you see different contents, different type of thing, and for every different thing you are getting different data. The one option is that, for example, if there is a drop down, let's create a drop down, baby. Let's create a drop down. So one option is for the drop down, option 1, get all the data before only for the drop down, but GraphQL have variables, so for specific drop down option you select, you get that data only, nothing else. You select it, you will get that. This is the perfect. You must specify an operation type and a name in a GraphQL document to use. Now in our client code we can simply pass a different variable rather than needing to construct an entirely new query. In general, this is also a good practice for denoting which arguments in our client code we can simply pass a different variable rather than needing to construct an entirely new query. In general, this is also good practice for denoting which arguments in a query are expected to be dynamic. We should never be doing string interpolation to construct queries from user supplied values. Okay. Variable definitions. The variable definitions are the part that looks like episodes in the query above. It works just like the argument definitions for a function in the typed language. It lists all of the variables prefixed by $, followed by their type, in this case episode, $episode. So variables, how you define the variable? So variables are just defined like by $. Variables, simple, $type, and give the value. All declared variable must be either scalar, enum, or input object type. So if you want complex object type, you need to know the input type that matches. Variable definitions can be optional or required. In case above, since there isn't an exclamation mark, it's optional, but if the field you are passing the variable into requires non-null, the variable has to be. To learn more about the syntax and the schema and type पेज पे जाओ. डिफ़ॉल्ट वेरिएबल, द डिफ़ॉल्ट अगर तुमने ऐड कर दिया तो उसमें ऑप्शन की ज़रूरत ही नहीं, मतलब वो डिफ़ॉल्ट है, ऑप्शनल है. अब अगर ज़रूरत भी होगी तो कोई दिक्कत नहीं, वो अपने अवेलेबल द डिफ़ॉल्ट वैल्यूज आर प्रोवाइडेड फॉर ऑल. You can call the query without passing the variables if any variables are passed as part fragments. Now coming to fragments, let's say we have a relatively complicated page in our app which lets us look at two heroes side by side along with their friends. You can imagine that such a query could quickly get complicated because we would need to repeat the fields at least once, one for each side of the comparison. That's why GraphQL includes the reusable units called fragments. So fragments are something very pretty. Why? Because you can now, you don't need to call that same query again and again, but you defined a query that can use that same thing for both. कैरेक्टर के अंदर नेम यूज़ करेगा, वेयर इज इन फ्रेंड नेम यूज़ करेगा, एपिसोड एपी. Using variables inside the fragment, it is possible for fragment to access variable declared in the operation as well. Variable तुमने define किया, int equal 3, episode empire comparison. सबको रिकॉर्ड कराइएगा. Inline fragments, like many other types, okay, so मतलब kind of you can pass the variable with it. It's kind of now practically dependent, I suppose. Like for example, मैंने int declare किया $first, so I can declare friend connections first. एक दो तीन. I declared 3, 1, 2, 3. Inline fragments, like many other types system, GraphQL schemas include the ability to define interface and union types. You can learn more about that. Interface तुम declare कर सकते हो, ठीक है. Okay, if you are querying a field that returns an interface or a union, you will need to use inline fragment to access data or underline concrete type. It's easiest. Like for example, episodes, oh, dot 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 on primary function, dot 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 on height. So what's the problem? Episode check. In this query, hero fields return the type character, which might either be a human or a droid, depending on the episode argument. In the direct selection, you can only ask for the fields on the character interface such as name. To ask for a field on a concrete type, you need to use inline fragment with a type condition because the first fragment is labeled as dot 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 on droid प्राइमरी फील्ड. ओके, जो अभी तक तुम डॉट 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 करके लिखा के आ रहे थे वो एक तरह से वही था. हाँ, तो हम लोग देख ही चुके हैं इन लाइन करके. नेम फ्रैगमेंट कैन ऑल्सो बी यूज इन द सेम वे सिंस नेम meta fields, as we have seen with our union types, there are some situations where you don't know what you will get back from the GraphQL service, so you need way to determine how to handle that data. GraphQL allows you to request underscore type name, a meta field, at any point in a query to get the name of the object type you want. Text underscore type name human. तुम क्या चाह रहे हो? डॉट 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 ऑन ह्यूमन नेम, डॉट 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 ऑन ड्रॉइड नेम. अगर टाइप नेम ऑन ह्यूमन है तो मुझे बस ह्यूमन कर दे दो बस. सर्च in the above query, search text and returns a union type that can be one of the three options. Without underscore type name field, it would be impossible for a client to tell the different types apart. All the fields name beginning with two underscores are reserved by GraphQL. In addition, underscore type name, GraphQL service provides the underscore schema underscore type meta fields, which exposes the introspection system. Directives. We discussed above how variables enable us to avoid doing manual string interpolation to construct dynamic queries. Passing variables in arguments solves the large classes of the problem, but we might also need a way to dynamically change the structure of the and shape of our queries using variables. For example, we can imagine a UI component that has a summarized and a detailed view, where one includes more fields than the other. Passing variables and arguments solves large class of these problems, but we might also need a way to dynamically change the structure. So query episode with friends boolean. Oh, if you know it is false तो नहीं देना, और अगर यही चीज़ मैं इसको ट्रू कर दूँ. भाई ये सब फीचर है इसके अंदर. Try editing the variable from construction for with friends. We need to use feature in GraphQL called a directive. Specifically, an executable directive can be attached to a field @include. That's the directive. F boolean @skip F boolean. Skip this field if the argument is true. We can write skip this field अगर ये true है. Simple. Directives can be useful to get out of situation where you otherwise would need to do string manipulation to add or remove fields in your query. Server implementation may also add experimental features by defining completely new. Looking for information how to define directives that can be used to annotate schema types for more. Next steps, recap. A GraphQL operation that reads the data starts at a query root operation and traverses the field in the selection set down to the leaf value, which will be scalar or enum types. Field can accept arguments that alter the output of the field. Operations can be used query, mutation or subscription keyword to indicate their type. The operation type keyword can be omitted for the certain query operations. Operations should be given a unique name which make the request more expressive. Field aliases allow you to rename the response keys including the same field multiple times. Variables are preceded by $character and can be used to provide dynamic values too. A fragment is a reusable selection set of fields that can be used to needed in a multiple queries. Executable directives can be applied to query to change the result of a GraphQL query. when executed. All the special compliant GraphQL services. Now that we understand the ins and outs, how to read the GraphQL. So now we are completed with the queries, and there's a lot more, and it was an interesting thing that we got to know about. Now we have mutation, subscriptions, validation, execution process, and then something very different. So we'll now cover things again next time. That's all about the GraphQL, and we will be ending this thing. Let's download that so that next day save to file GraphQL downloads. Just will down save now. Reset the canvas config. I downloaded that. Thank you very much.